Hi everyone, this is the review for test number 4, which is on chapter 7, Roots and Radicals. I'm going to try to go through as many problems as I can. Some I'll probably skip over if they're similar, and all of the answers can be found at the end of the document. Okay, so in the first problem we need to find the square root, and remember we're assuming that all variables represent positive real numbers because if we didn't assume that, we would need to put absolute value bars around any of our terms that we're taking an even root of. So in number 1, we want to find the square root of 144. So in other words, we're looking for a number that we would square that would equal 144. And that number is 12. The square root of 144, the principal square root, the positive answer is 12. Now, if you want to find a square root, 144 is what we call a perfect square because you can take the square root of 144 very easily. If you don't have a perfect square, then you need to break that number down, and we'll see that as we work along these problems. In number 2, we have x to the 28th, and I'm taking the square root. So the easiest thing to do is take the root index, and the index is the little number inside the radical house, but you won't see a 2 in here because it's understood, but it is there. So the easiest thing to do is take the exponent and divide it by the index, and 28 divided by 2 gives you 14. So the answer here would be x to the 14th. Okay, and number 3, we're looking now for a cube root, and I know that because my index is a 3 for each of these. So now I want to think of a number that I would cube that would equal negative 64. And you can take cube roots or any odd root of negative numbers. Unlike square roots and even roots, you cannot take the square root or even roots of negative numbers because you'll end up with an imaginary number. So what number cubed gives you negative 64? And that would be a negative 4. Keep in mind, anytime you take the cube root or any odd root of a negative number, it will stay negative because an odd number of negatives will give you a negative answer. And then again, I'm going to take my index and divide it into my power, and 3 goes into 6 2 times. So my answer would be negative 4x squared. So that's letter B. In number 4, we have a radical and we have a quotient inside. So one thing you can do is use the quotient rule for radicals, and you can split the numerator and denominator up. And we can make this into the cubed root of x to the 12th over the cubed root of 216 y to the 6th. And if I take each cubed root individually, I would get x to the 4th in the numerator. And what number cubed gives you 216? That would be 6, and then the cube root of y to the 6th is y squared. So my answer here is going to be letter A. Again, we're finding the root, and we have a mixture here. In number 5, we have a negative on the outside, so that means our answer is going to remain negative. And the fourth root of 16 is asking us what number to the 4th power would give us 16. That would be 2. 2 to the 4th is 16. For the fourth root of x to the 12th, 4 goes into 12 3 times, and 4 goes into 8 2 times. So you would have negative 2 x to the 3rd y squared, which is letter D. In number 5, we're taking the 5th root, and we're going to do the same thing we did in number 4, where we can split this into the 5th root of 243x to the 5th over the 5th root of y to the 15th. So I'm using the quotient rule for radicals. And now I want to find the 5th root of 243. So one of the things you can do is you can make a factor tree and pick any two numbers that multiply to give you 243. Okay, so I know that 3 goes into 243 81 times. And I'm going to break this down to primes. I know 81 is 9 times 9. And then we know, of course, the 9s break down into 3 times 3. And then I'm going to grab that 3 up there and bring that down as well. So here's my factor tree. When you're looking for a fifth root, you want to find a group of 5 of the same number. And here's my group of 5. So 3 to the fifth is 243. So that's how I know that's the fifth root of 243. And then 5 goes into 5 one time, so I have x to the first. And then for the fifth root of y to the 15th, 5 goes into 15 three times, so that would be y to the third. So here my answer is letter B. In number 7, it says simplify. And again, we're assuming all variables represent any real number. So when I take the square root of x plus 9 squared, because we're assuming that the variables are positive, I don't have to worry about these absolute value bars. Okay, if my directions didn't say that, I would need to put absolute value bars around any answer when it's an even radical, so square roots, fourth roots, to ensure that my answer would remain real. So here I am going to do the same thing I've been doing. I'm going to take that 2 and divide it into this 2. And 2 divided by 2 is 1. So my answer is just x plus 9. If my directions did not say assume all variables represent positive real numbers, my answer would have been C. I would have to ensure that what is inside the radical for that variable would be positive. Okay, in number 8, we're using radical notation to write the expression and simplify if possible. So remember what we have here is a rational exponent. It's just an exponent that's a fraction, right? Fractions are ratios. And all I'm going to do is rewrite that. So the 64 is going to go inside the radical. The denominator is your index. So that's going to go there. That's a cubed root. And then the 4 here in the numerator is your power. So one way to write it is like that. And if I break this down, we know the cubed root of 64 is 4. And if I do 4 to the 4th power, 4 times 4 times 4 times 4, I get 256. So my answer is B. Okay, here we have the quotient rule, and we're using this to divide and to simplify. One thing you can do is you can try reducing. So I have the square root of 20. I can simplify that. The square root of 4 times the square root of 5 equals the square root of 20. So I'm trying to find a perfect square that goes into 20, which would be the square root of 4. And then the square root of 64 just simplifies to 8. So if I reduce this further, I would have 2 root 5 over 8. And then I'm going to reduce. So this is really just 2/8, which reduces to 1/4. So your answer is the square root of 5 over 4, letter C. In 10 and 11, we're using the product rule to multiply. So as long as you have the same root index, you can multiply them together. But check first to make sure that you can simplify. But before you go and multiply, because then you'll get big numbers for no reason. So here I'm just going to take the cubed root, and I'm going to leave this as 27 times 64. And then I know m to the third times m to the third is just m to the sixth. Now I'm going to break this down. So I can take the cubed root of 27 evenly, which is 3. 3 times 3 is 27. And the cubed root of 64 is 4. 4 times 4 times 4 is 64. And I know that the cubed root of m to the sixth is just m squared, because 3 goes into 6 2 times. And then if you multiply them, you get 12m squared. So letter C. In number 11 rather, I can't take the square root of 50 evenly, and I can't take the square root of 18 evenly, but I can break them down separately. Sometimes it might help to multiply the two numbers together, and then you're able to, maybe take a square root evenly. So we can try multiplying 50 times 18 and see what we get. And 50 times 18 is 900, and you can take the square root of 900 evenly. So instead of breaking it down, each one separately, I'm just going to multiply them together. I'm going to use the product rule for radicals and put them under one radical, because I can do that because they're both square roots. And if I multiply them together, I would get 900. And the square root of 900 is 30, because 30 squared is 900. So that is C. In number 12, we are simplifying. So I need to break down 117. I know that 3 goes into 117 because if you add the digits, 1 plus 7, it's 9. I know 3 goes into 9, so 3 will also go into 117. So I need to figure out what that would be. So I'm going to do 117 divided by 3, and I get 39. So I know that I can break this down, okay? I know that 39 breaks down into 3 times 13. So I'm going to try 117 divided by 9. Okay, so I know 9 goes into 117 13 times. So this actually breaks down into the square root of 9 times the square root of 13, because 9 times 13 gives me 117. And we know the square root of 9 is 3, and the square root of 13, you can't break it down anymore. 13 is prime, so your answer is A. For number 13, I'm trying to break down the square root of 98. So I'm pretty sure 49 goes into 98 2 times, okay? 49 times 2 is 98. The square root of 49 gives me 7, and then I would leave the 2 inside the radical, okay? If I want to take the square root of q to the 7th, again, remember there's an invisible 2 in here, and we're just going to divide the index into the power. So 2 goes into 7 3 times, so a k to the third is going to pop out. And there's a remainder of 1, so the remainder goes back inside. And then 2 goes into 8 4 times, and there's no remainder. So your final answer is 7k to the third, q to the fourth, times the square root of 2k, which is letter A. Now we're looking at subtracting and adding. So we can add and subtract radicals as long as they have the same radicand or like radicals, which they don't. So we have to try to make them the same if we can. So we're going to break these down. So I know that for 48, I can break the square root of 48 down into the square root of 16 times the square root of 3. And I know that I can break down 75 into the square root of 25 times the square root of 3. And I can break down the square root of 192. I'm going to guess I can break it down into the square root of 3 and something. So 192 divided by 3 gives me 64. Okay, and that was just a guess since all the other ones had a root 3 in them. And now I'm going to simplify. So the square root of 16 turns into a 4. So I would have negative 6 times 4, which would give me negative 24 root 3. And then I know the square root of 25 is 5. 9 times 5 gives me 45. And it's 45 square root of 3. Okay, and I apologize for my marker. And then square root of 64 is 8. 8 times negative 2 is negative 16 square root of 3. Since we have root 3's all throughout, we can combine these. They're all like radicals. So I'm just going to add the coefficients on the outside, which will be negative 24 plus 45 minus 16. And I get 5. So my answer would be 5 root 3. So that would be letter A. In number 15, you're multiplying, and be really careful. Don't fall for the trap where you just square each of those. Remember, it's a binomial, and you have to write it twice and FOIL it. So the square root of 7 plus the square root of 11 squared really just means the square root of 7 times the square root of 11 times itself. Okay, so if I use FOIL, I'm going to do first times first. Square root of 7 times the square root of 7 is just 7. Outer, that's going to give me the square root of 7 times 11. Inner, and then last times last. So I can combine like terms. 7 plus 11 gives me 18. And I have two square root of 77s. So my final answer is 18 plus 2 root 77, which would be letter B. Number 16, again, we're adding here. We have like radicals. They're both cube roots. So I'm just going to add the outsides, 2 plus 13. That gives me 15. And then don't forget to put the 3 back in there. It's still a cubed root of 3. So this will be letter B. So you were asked to watch a video on rationalizing, and I know your labs in the Learning Support Center asked you about rationalizing. So we typically don't like radicals in the denominator, and one way to get rid of it is to do this technique called rationalize. We're going to multiply the top and bottom, the numerator and denominator, by whatever the denominator is. So the square root of 11 over the square root of 11, which this actually just equals 1 in disguise. And we have two fractions now, so we multiply straight across. If we use the product rule, we get the square root of 22. And in the denominator, anytime you multiply the same radicals together, you just end up with the radicand, 11. And then that would be your final answer. Remember, you cannot divide these into each other because the 11's not under a radical. So please don't be tempted to try to do that. Okay, number 18, again, I'm going to rationalize. This time I have to employ what are called the conjugates. So I'm going to take whatever my operation is there. In this case, I'm subtracting. So now I'm going to add. So I'm going to multiply by the square root of 5 plus 8 in the top and the bottom. Okay, because I'm multiplying by a 1 in disguise. So now I'm just going to distribute the 3, and I would get 3 root 5 plus 3 times 8. And then in the denominator, I'm going to kind of FOIL, except if you try to FOIL, you'll find that the outer and inner terms are going to cancel. So all we really have to multiply is the first times the first. Root 5 times root 5 is just 5. And then the last times the last. Negative 8 times 8 is negative 64. And then I'm going to simplify. I would have 3 root 5 plus 24 over 5 minus 64 is negative 59. And I can't really simplify that any further, and the answer that is closest to that would be letter B. Notice the negative is next to the fraction bar, and that is okay. Remember, you can take that negative and move it here. You could even put it up next to the 3, as long as it's somewhere in the problem. The fraction remains negative. Okay, the next 4 are all about solving. So if I want to solve a radical equation, you want to make sure the radical is isolated. And in this case it is. It's by itself. It can have things in the radicand underneath. It just can't have things around it. Like in 21, we would want to move that 3 away. So here, to undo a radical, we're going to, in this case, since it's a square root, we're going to square both sides. And when you square the square root of x plus 5, you just end up with x plus 5. And when you square 9, you get 81. And then if I solve for x, I'm going to subtract 5. And 81 minus 5 gives me 76. And it's always a good idea to check your answer, especially when you have an even root, because remember, if you get a negative under your radical, you won't be able to take the square root or any even root of it, as it will give you an imaginary number. Number 20, we have the radical isolated. So again, it's a square root. I'm going to square both sides. When I square the square root of 5x, I'm just left with 5x. And when I square negative 6, I get positive 36. And then I'm going to solve for x, so divide by 5, and you get x equals 36 fifths. Okay, here's the problem. When you go and take 36 fifths and you try to plug it back in, you'll have the square root of 5 times, and then x was 36 fifths, so just do 36 divided by 5, and the answer you get, as you can see, is 6. However, when you go to the problem, it says the answer should be negative 6. So this is what we call an extraneous solution. It's just a solution that doesn't quite make sense in this case. So here the answer is A, which, remember, that symbol just means no solution. It also means empty set. So the answer would not be 36 fifths. So remember, you want to always check your answer. For roots that are odd, you really won't run into an issue. It's good to check just to make sure your answer is valid and that you calculated everything correct, but you won't end up with imaginary numbers because you can take odd roots of negatives. So here, as I said earlier, you need to isolate the radical. So we need to get rid of this 3. And when I do that, I would be left with now the cubed root of 2x plus 1 equals negative 3. And now we're going to undo a cube root, so we're going to cube both sides. And when you do that, you're left with 2x plus 1 equals negative 27. Negative 3 to the third is negative 27. And then I'm going to subtract 1, and you would get this. And then I'm going to divide by 2. And negative 28 divided by 2 is negative 14. And you can certainly go ahead and plug that in, and it will work out. In 22, I have the radical isolated. So again, I'm going to square both sides. And this time I'm left with 7x minus 27. But here, remember, you're going to have to FOIL. So keep in mind, this really means 5 minus x times 5 minus x. Please don't fall for the trap and do 5 squared minus x squared. That is wrong. When you FOIL that, you're going to get the following. Okay, now I have a quadratic, right? We talked about them. So that's an x squared. I need to make one side 0. So I'm going to subtract the 7x and put it here with the negative 10. And I'm going to add the 27 and put it here with the 25. And now you would be left with, if I rewrite this, it would be x squared minus 17x, and then 25 plus 27 is 52 equals 0. And I want to try factoring this first. So I need factors of 52 that add up to a negative 17. Okay, and if you don't know where to start with 2 and see 2 goes into 52, right? Start with 1 actually, so 1 times 52, but you can't get a negative 17 from that. 2 goes into 52 26 times. I can't get a 17 from that. 3 does not go into 52. 4 does go into 52. So 4 goes into 52 13 times, and I can get a 17 from that. Negative 4 times negative 13 is positive 52, and negative 4 plus negative 13 is negative 17. So then we're going to, remember, use the zero product property. I'm going to set both of these equal to 0 and solve. So if you use some mental math, you would get 4 and 13. But again, you want to check and be sure that they both work. So if I plug in, let's use our calculator. We've got the square root of 7, and then parentheses. One of my answers was a 4. Okay, and then let me go back and see again what the problem was. So I have to do minus 27. Okay, so minus 27. Okay, that equals 1. And then on the other side, it was x minus 5, I believe, or was it 5 minus x? It was 5 minus x. So on the other side, it was 5 minus x. So 5 minus 4 is also 1. Okay, now, so 4 is good. The other answer I got was 13. So I'm going to change these 4s to 13s and see if I get the same answer. So I got an 8. I need to make sure I get an 8 here, changing the 4 to a 13. And I don't. I get a negative 8. That means that both sides are not equal. That would produce a false statement. So that means that 13 is extraneous. The only answer is 4. So the answer for number 22 is letter A only. Okay, and the last portion of the notes or the study guide all refer to complex numbers, which and it's the complex numbers are made up of the real number system and the imaginaries. So it allows us to be able to take even roots of negative numbers. So in 23, if this was just a positive 121, I would be able to take the square root of it. It would give me 11, but it's not. There is no number that you could square that would give you a negative 121. So what I have to do is pull out the square root of negative 1 times the square root of 121. And the square root of negative 1 is I, and the square root of 121 is 11, because 11 times 11 is 121. So my answer is 11I, which would be letter C. Multiplying and dividing doesn't always work the way we like it to and the way we're used to with radicals. So for instance, in 24, you're multiplying. You can't just multiply the 3 and the negative 125. You first have to simplify the square root of negative 125. So the first thing I'm going to do for this is just pull out of there a negative 1. And I also know that I can break down the square root of 125 into 25 times 5. Okay, and then don't forget I have that square root of 3 there as well. Okay, so I'm going to go through now, and I know that the square root of 25 is 5, and I know the square root of negative 1 is the imaginary number I, and you can't take the square root of 5 or the square root of 3, so just multiply them together. You would get 5I times the square root of 15. Okay, so the same thing's true with 25. Don't be tempted to just divide negative 42 by negative 7. First, simplify it. So perfect square that goes into 42. And can't really, let's see, 4, 9, 16. Nope, there is no number. So all I can do there is just pull out a square root of negative 1 and a square root of 42. And in the denominator, all I can do here is pull out a square root of negative 1 and a square root of 7. Okay, now you can take this, and you know that these are both i's, so they're going to go away. And we can divide now. The square root of 42 divided by the square root of 7, which is written like this. And then that would just equal the square root of 6. So that would be letter C. Okay, and that would have worked out if you had just divided the negative 42 by the negative 7, but it doesn't always. So pull out the i's first, and then simplify and use the quotient rule, because the rules don't work the same way in that world. Okay, in 26, I am subtracting. Subtracting looks very similar to multiplying with complex numbers, so be really careful. That's a minus sign. Remember, when you're subtracting, you're going to change the signs. So this is going to turn into a positive, and that's going to turn into a negative, right? Because it's like you're distributing a negative 1. So now 9 plus 7 gives me 16, and 4i plus negative I is positive 3i. So the answer there is C. Okay, if you don't like changing signs, if that confuses you, really that's what we're doing. You can think of it as this. So this is also, if I rewrite it over here, 9 plus 4i, and then you're distributing the negative. So that would turn into a 7, and then distribute the negative. That would turn into a negative I, and then just collect your terms. So 9 plus 7 is 16, and 4i minus 1i is positive 3i. In 27, you're going to rationalize. You're going to get rid of that denominator. So we're going to multiply by, this time, what's called the complex conjugate. You're just going to change the sign of the denominator. And it's going to do the same thing that happened when we have radicals, where it will cancel out the middle term. So now we're going to FOIL. So I'm going to have 9 times 9, which is 81. Outer terms, 9 times 4i, which is 36i. Inner terms, 9i times 9 is 81i. And then 9i times 4i gives me 36i squared. And then in your denominator, remember the inner and outer terms will cancel, just like they did with radicals. So all I have to do is first times first, which is 81. And then I've got last times last, negative 4i times positive 4i is negative 16i squared. I squared is equal to negative 1. So everywhere there's an I squared, you're going to replace that with a negative 1. So this is really 81, and then 36 plus 81 gives me 120 or 117 I in the middle. And then 36 times negative 1, that really turns into negative 36. Okay, so I'm getting that because I squared equals negative 1. Okay, you want to remember that. And if you don't know why, make sure you watch the 7.7 video, and I explain it there. Okay, and then I'll have 81 minus 16 times negative 1, so that'll turn into a plus 16. So if I go and collect my like terms now in the top, 81 minus 36, that gives me 45 plus 117i. And then in the denominator, 81 plus 96 gives me 97. And since we're adding and you have the same denominator, you can split it up. And written in a plus bi form would be 45 over 97 plus 117 over 97i. Okay, and always see if you can simplify. And you can't simplify those, so you're done. Okay, in 28, you're asked to find I to the 43rd. So there's a pattern, and again, if you watch the video for 7.7, you'll learn what it is. And basically, it talks about how I is just I. It's the square root of negative 1, right? And I squared, we know, is negative 1. I to the third is made up of I times I squared, which is negative I. And then I to the fourth, think of it as I squared times I squared. So when you get to I to the fifth, it's just I to the fourth times I. And you're back to I again, and the pattern just keeps repeating. So I to the sixth would be negative 1, I to the seventh would be negative I to the eighth would be 1, and then you're back up to I to the 10th, which is I again, and it just keeps repeating. So it repeats after every 4. The powers represent your remainders. So when you have a remainder of 1, your answer is going to be I. When you have a remainder of 2, your answer is going to be negative 1. Remainder of 3, it's going to be a negative I. And then no remainder would be a 1. Okay, so since the pattern repeats itself after every 4, right? If you divide by 4, the highest remainder you can get is a 3. You're never going to get a remainder of 4 if you divide by 4. The highest the remainder will be is 3. So think of I to the fourth essentially as just no remainder. So to find what I to the 43rd is, you could certainly sit there and figure it out, but it would take kind of long. Or you could just do divide 4 into 43. And again, I'm dividing 4 because it repeats after every 4. And 4 goes into 43, 10 times. 10 times 4 is 40. And then we have a remainder 3. So if I remember remainder 3 tells me my answer is going to be negative I. So I to the 43rd really equals negative I, so my answer would be B. And that's the end of the video. Practice this. Make sure you're practicing anything that you're a little weak on, and you'll be fine on the test. Have a great day, everyone, and let me know if you need anything.